For over a decade, the electric vehicle industry has been locked in an arms race. Billions of dollars were spent. Thousands of engineers were hired. Countless promises were made about the future of transportation. Every major automaker on the planet poured resources into catching Tesla, into proving that the upstart from California was just an early mover advantage waiting to be erased. And for a while, it seemed like they might succeed. Legacy automakers announced ambitious electrification plans. Startups raised billions in funding. Battery technology improved across the industry. Charging networks expanded. The gap between Tesla and everyone else appeared to be closing. Then Tesla unveiled something that changed everything. A motor so advanced, so efficient, and so far ahead of what anyone else has developed that industry analysts are now saying the quiet part out loud. The electric vehicle war might already be over, and Tesla has won. This is not about incremental improvement. This is not about being slightly better than the competition. What Tesla has created represents a fundamental leap in electric motor technology, the kind of breakthrough that takes years, perhaps a decade, for competitors to match. By the time they catch up, Tesla will have moved on to the next generation. This is the story of how one motor design ended the electric vehicle competition before most people even realized the race was finished, and why what comes next will reshape not just the auto industry, but the entire global economy. To understand why Tesla's new motor matters so much, you need to understand the fundamental challenge that has plagued electric vehicle engineering since the beginning. Electric motors are conceptually simple: pass electricity through copper windings, create a magnetic field, spin a rotor, generate motion. The basic principles have been understood for over a century, but turning those simple principles into a motor that can power a high-performance vehicle while remaining efficient, reliable, and affordable is extraordinarily difficult. The problem is physics. When you spin a rotor at high speeds, centrifugal force tries to tear it apart. The faster you spin, the greater the force. This creates a fundamental trade-off in motor design. You can build a motor that spins fast and generates massive power, but it will be heavy, require extensive reinforcement, and lose efficiency to internal stresses. Or you can build a motor that is efficient and lightweight, but it will not produce the kind of performance that makes electric vehicles exciting. For years, every electric vehicle manufacturer accepted this trade-off. Performance cars sacrificed efficiency. Efficient cars sacrificed performance. The physics seemed insurmountable. Tesla refused to accept that limitation. The solution they developed centers on a carbon fiber-wrapped rotor, a design that sounds simple, but required years of engineering refinement to perfect. By wrapping the rotor in carbon fiber, Tesla's engineers created a structure that could withstand centrifugal forces that would destroy a conventional motor. The carbon fiber acts like a compression sleeve, holding the rotor components together even at rotational speeds that were previously impossible. This single innovation unlocked capabilities that seemed like science fiction just a few years ago. The motor can spin at over 20,000 revolutions per minute. To put that in perspective, most high-performance electric motors top out around 15,000 to 18,000 revolutions per minute. Conventional automotive motors typically operate at far lower speeds. Tesla's motor operates in a regime that was previously reserved for specialized industrial applications, not consumer vehicles. But raw speed means nothing without the ability to convert that rotation into usable power. This is where Tesla's engineering becomes truly impressive. The carbon fiber wrapping does not just allow higher RPM. It keeps the rotor perfectly stable at those speeds, eliminating the vibrations and inefficiencies that plague conventional high-speed motors. A stable rotor means cleaner magnetic field interactions, which means more of the electrical energy gets converted into mechanical motion, rather than being lost as heat or vibration. The result is a motor that produces staggering torque from a standstill while maintaining efficiency at highway speeds. It is compact enough to fit in spaces that would be impossible for a conventional motor of similar power. It is light enough that it does not compromise vehicle dynamics, and it runs cool enough that it does not require massive cooling systems that add weight and complexity. The Model S Plaid was the first vehicle to showcase this technology, and the numbers it posted shocked the automotive world. 0 to 60 miles per hour in under 2 seconds, not approximately 2 seconds. not roughly 2 seconds. Under 2 seconds. A threshold that was previously the exclusive domain of million-dollar hypercars with internal combustion engines specifically designed for straight-line acceleration. But the Plaid isn't a stripped-down drag racer. It's a full-size luxury sedan with a complete interior, advanced technology features, and a range that makes it practical for daily driving. It can accelerate like a purpose-built race car, then drive 400 miles on a single charge, then do it all again after a brief charging stop. This combination was supposed to be impossible. The engineering trade-offs that govern electric motor design said you couldn't have both brutal acceleration and long usable range. You had to choose. Tesla's motor made that choice obsolete. The automotive industry took notice. Engineers at competing companies reportedly studied the Plaid's motor design and came away troubled by what they found. Not because they couldn't understand it, but because they understood it all too well. Replicating this technology would require years of development, billions in investment, and manufacturing capabilities that most automakers don't possess. But even the motor's performance isn't the most significant advantage Tesla has created. The real game changer is how they're manufacturing it. Building a high-performance electric motor is difficult. Building millions of them at consistent quality while keeping costs low enough for mass-market vehicles is nearly impossible. This is where most electric vehicle startups fail. They can create impressive prototypes, dazzle investors with specifications, and generate excitement with concept vehicles. Then they try to scale production, and everything falls apart. Tesla spent years building manufacturing capabilities that are arguably more valuable than the motor technology itself. During their recent investor presentations, Tesla revealed something that made competitors deeply uncomfortable. Their next-generation drive units are being designed from the ground up for manufacturability. Not just performance, not just efficiency, manufacturability. The goal is a complete drive unit, motor, power electronics, and gearbox. Combined, that costs approximately $1,000 to produce. $1,000 for a system that can propel a vehicle from 0 to 60 in seconds while maintaining range and efficiency that leads the industry. To put this in perspective, current industry estimates suggest that comparable drive units from other manufacturers cost 3 to 5 times as much. Some cost even more. The gap between Tesla's manufacturing costs and everyone else's isn't a small advantage, it's a chasm. And Tesla is widening that chasm with every production innovation they implement. The next generation motors are being designed to eliminate rare earth elements entirely. These materials, primarily sourced from China, have been a strategic vulnerability for the entire electric vehicle industry. They're expensive, supply chains are fragile, and their extraction carries significant environmental costs. Every automaker has been working to reduce rare earth dependence. Tesla appears to be on the verge of eliminating it completely. They're also dramatically reducing the amount of silicon carbide required in their power electronics. Silicon carbide enables more efficient power conversion, but is expensive and difficult to manufacture at scale. By redesigning their systems to use less of it, Tesla is cutting costs while maintaining the efficiency advantages that silicon carbide provides. These manufacturing advances compound on each other. Lower material costs enable lower prices. Lower prices enable higher volumes. Higher volumes create more manufacturing experience. More experience enables further cost reductions. It's a flywheel that accelerates the more it spins. This is why the comparison to competitors looks so unfavorable for everyone except Tesla. Look at the legacy automakers first. Ford announced its ambitious electrification plans with great fanfare, promising to challenge Tesla directly with vehicles like the Mustang Mach-E and the F-150 Lightning. The vehicles themselves are competent. In some ways, they are impressive, but Ford is losing money on every electric vehicle it sells, not breaking even. Billions of dollars in losses are being subsidized by profits from their internal combustion vehicle business. This is not a sustainable strategy. It is a holding action, an attempt to stay relevant while hoping that costs eventually come down enough to reach profitability. Every year that Ford loses money on electric vehicles is another year that Tesla extends its manufacturing advantages. By the time Ford figures out how to make money selling electric vehicles, Tesla will have moved even further ahead. General Motors faces similar challenges. They have invested heavily in their Ultium battery platform and have introduced vehicles that receive positive reviews, but profitability remains elusive. Their electric vehicle production volumes are a fraction of Tesla's. Their manufacturing costs are higher. Their software, particularly after the embarrassing struggles with their Super Cruise system and various technology glitches, lags behind what Tesla offers. Toyota, the world's largest automaker, has been even slower to adapt. They bet heavily on hydrogen fuel cells and hybrid technology, dismissing battery electric vehicles as impractical for mainstream adoption. That bet is looking increasingly mistaken. Toyota is now scrambling to develop competitive electric vehicles years behind where they need to be. Their first serious attempts have been underwhelming, plagued by recalls, limited range, and uninspiring performance. Volkswagen, which announced with great fanfare that it would become the world's leading electric vehicle manufacturer, has struggled with software problems, production delays, and quality issues. Their ID series of vehicles has found buyers in Europe but has not made significant inroads in the crucial American and Chinese markets. The company recently announced significant software problems and layoffs and cost-cutting measures, a sign that their electric vehicle transition is proving more difficult than anticipated. The startups aren't faring any better. Lucid Motors produces what many consider the most technologically impressive electric vehicle currently available, with range and efficiency figures that match or exceed Tesla's best. But Lucid is burning through cash at an alarming rate while producing vehicles in very small volumes. Their cars cost over $70,000 at a minimum, which limits their addressable market. They have repeatedly missed production targets. Their path to profitability remains unclear. Rivian generated tremendous excitement with its electric truck and SUV, attracting massive investments from Amazon and others. But the company is losing money at an even more alarming rate than Lucid. Production costs are far higher than projected. Every vehicle they deliver represents a significant financial loss. Without continued access to capital markets, their survival is not guaranteed. The only competitor that seems to pose a genuine threat is BYD, the Chinese manufacturer that has grown to challenge Tesla's position as the world's largest electric vehicle producer. BYD has mastered high-volume, low-cost manufacturing in a way that no other Tesla competitor has matched. They are expanding globally, entering markets in Europe, Southeast Asia, and Latin America. But BYD's success has come primarily in the budget and mid-range segments. They compete on price, not on cutting-edge technology. Their vehicles are adequate, but they do not push boundaries. They are not winning hearts, they are winning wallets. And even that advantage may be limited. BYD depends heavily on the Chinese market, where government support provides significant advantages. As they expand internationally, they face tariffs, regulatory scrutiny, and established competitors who understand local markets better than a Chinese company can. Tesla occupies a different position entirely. They compete at the premium end of the market, where margins are higher and brand loyalty is stronger. Their vehicles command prices that provide healthy profits while still offering value that customers perceive as superior to alternatives. They are not trying to be the cheapest option. They are trying to be the best option. And increasingly, that is exactly what they are. But even all of this understates Tesla's true advantage. Because what makes Tesla dangerous isn't just their motor technology, or their manufacturing capabilities, or their brand strength. It's the combination of all of these factors with advantages that have nothing to do with building cars. Start with the data. Every Tesla on the road is collecting information about how humans drive. Every mile driven generates data that feeds back into Tesla's systems, improving their understanding of driving patterns, road conditions, edge cases, and the countless variations that make autonomous driving so difficult. Tesla has accumulated more real-world driving data than every other autonomous vehicle program combined. Not slightly more, overwhelmingly more. This data advantage compounds over time. More data enables better algorithms. Better algorithms enable more capable vehicles. More capable vehicles attract more customers. More customers generate more data. The cycle reinforces itself continuously. Competitors cannot buy this advantage. They cannot shortcut it. They cannot acquire it through partnerships or investments. The only way to accumulate this kind of data is to have millions of vehicles on the road, collecting information continuously for years. By the time any competitor reaches Tesla's current data position, Tesla will have moved even further ahead. Then there's the battery situation. Tesla has invested billions in battery production, building their own manufacturing capabilities rather than depending entirely on suppliers. Their partnership with Panasonic provided the foundation, but Tesla has been systematically reducing that dependence, developing their own cell designs and production processes. The 4680 battery cell, despite production challenges that have taken longer to resolve than initially hoped, represents a fundamental advance in battery technology: higher energy density, lower cost per kilowatt hour, improved thermal characteristics, simpler manufacturing. When fully scaled, 4680 production will give Tesla a cost and performance advantage in the single most expensive component of any electric vehicle. Competitors are largely dependent on external battery suppliers, which means they are competing for limited production capacity, paying whatever prices the market demands, and accepting whatever technology their suppliers choose to develop. Tesla controls its own destiny. The vertical integration extends throughout the company. Tesla designs its own chips for vehicle computers and autonomy processing. When the global semiconductor shortage crippled other automakers, Tesla rewrote their software to work with available chips and kept production running. They designed their own seats, their own infotainment systems, their own power electronics. Every component they bring in-house is another area where they can optimize for their specific needs, rather than accepting compromises imposed by external suppliers. And then there's the global manufacturing footprint. Fremont was the beginning. A former General Motors and Toyota plant that Tesla transformed into one of the most productive automotive factories in North America. Shanghai followed, a factory that went from bare ground to producing vehicles in under 2 years, a pace that legacy automakers said was impossible. Berlin came next, bringing Tesla manufacturing to Europe. Austin, Texas, houses what may become the largest factory in North America, producing both vehicles and batteries. But Tesla isn't stopping there. Mexico is next, with a factory planned for the Monterrey region that will produce next-generation vehicles at costs even lower than current facilities can achieve. The combination of lower labor costs, proximity to the American market, and Tesla's manufacturing expertise will create a production facility optimized for affordable electric vehicles that could transform the market. Saudi Arabia has announced plans for Tesla manufacturing, giving the company a foothold in the Middle East, with backing from a government eager to diversify beyond oil. Chile provides access to lithium, the critical battery material, with potential for mining and processing facilities that further secure Tesla's supply chain. India, the world's most populous country and a potentially massive electric vehicle market, is in discussions for local manufacturing that would unlock 1 billion potential customers. This isn't just expansion, it's global industrial infrastructure being built at a pace that no competitor can match. And then there is the charging network. For years, Tesla's supercharger network was dismissed as a nice-to-have, a convenience for Tesla owners, but not a strategic advantage. That analysis was catastrophically wrong. The supercharger network has become one of Tesla's most powerful competitive weapons. Tesla's charging stations are everywhere. They are reliable, they are fast, they are located in convenient places with amenities nearby. They work seamlessly with Tesla vehicles. No apps to download, no payment confusion, no compatibility issues. You pull in, plug in, and charge. Every other charging network struggles with reliability, accessibility, payment systems, or some combination of all three. Horror stories of broken chargers, incompatible connectors, confusing payment apps, and abandoned charging sessions are commonplace among non-Tesla electric vehicle owners. This disparity has become so pronounced that other automakers have essentially surrendered. Ford, General Motors, Rivian, Volvo, and others have announced they will adopt Tesla's charging standard, giving their customers access to the supercharger network. They are admitting publicly that they cannot compete with Tesla's charging infrastructure. Think about what this means. Tesla's competitors are now dependent on Tesla for a critical part of their customer experience. Tesla will profit every time a Ford or General Motors customer charges at a supercharger. Tesla controls the infrastructure that makes their competitors' vehicles usable. This would be like Apple allowing Samsung phones to only work properly with Apple's cellular network. The competitive implications are staggering, but perhaps the most underappreciated advantage Tesla possesses has nothing to do with cars, batteries, or charging. It is called Dojo. Dojo is Tesla's custom supercomputer, designed specifically to train artificial intelligence systems on the massive amounts of video data generated by Tesla's vehicle fleet. Training artificial intelligence requires enormous computational resources. The companies at the forefront of AI development spend billions of dollars on hardware from NVIDIA and on cloud computing services from Amazon, Google, and Microsoft. Tesla decided to build its own. Dojo is designed to process video data more efficiently than any general-purpose computing system. It is optimized for exactly the type of data Tesla collects, and exactly the type of training that autonomous driving systems require. When fully operational, Dojo will give Tesla the ability to improve its autonomous driving capabilities at a pace that competitors simply cannot match. This gives Tesla a decisive pace advantage. Currently, most autonomous vehicle programs are limited by computational resources. They have more data than they can process, more experiments than they can run, more ideas than they can test. Computing power is the bottleneck. Tesla is removing that bottleneck. With Dojo, Tesla can train new models faster, test more hypotheses, iterate more rapidly, and improve their systems more continuously than any competitor. They are not dependent on external suppliers for critical AI infrastructure. They are not competing for limited cloud computing resources. They are not waiting for NVIDIA to ship enough chips. They are building their own AI infrastructure tailored to their specific needs, at a scale that dwarfs any other effort in the autonomous vehicle space. This is why Tesla increasingly does not feel like a car company at all. They are a vertically integrated industrial conglomerate with capabilities spanning manufacturing, energy, computing, and artificial intelligence. They happen to produce cars, but cars are almost becoming a secondary concern. The motor that started this story, the carbon fiber-wrapped rotor that spins at 20,000 revolutions per minute and produces acceleration that rivals hypercars, is just one piece of a much larger picture. It is an impressive piece, perhaps the most impressive piece of electric motor engineering ever created. But it exists within an ecosystem of advantages that reinforces and amplifies its impact. Better motors enable better vehicles attract more customers generate more data enables better autonomy justifies higher prices create more profit funds more research creates better motors, data drives the cycle, and the cycle continues, accelerating with each revolution. It is accelerating. This is why the electric vehicle war is effectively over, not because Tesla's competitors are incompetent. Many of them employ brilliant engineers and have access to enormous resources, but they are caught in a position where catching up requires closing multiple gaps simultaneously. In motor technology, in battery production, in manufacturing efficiency, in software capability, in data accumulation, in charging infrastructure, and in AI development. Closing any one of those gaps would be challenging. Closing all of them while Tesla continues to advance is effectively impossible. The motor that spins at 20,000 revolutions per minute is not just an engineering achievement. It is a symbol of what Tesla has become. A company that solves problems others consider unsolvable, at costs others consider unachievable, at speeds others consider impossible. Elon Musk's new engine did not just improve Tesla's position in the electric vehicle race. It ended the race entirely. What comes next is not competition in any traditional sense. It is Tesla continuing to extend advantages that are already overwhelming, while competitors struggle to remain relevant in a market that has fundamentally shifted beneath their feet. The electric vehicle revolution is happening, but it's not happening the way most people expected. It's not a transition to a new automotive paradigm where multiple competitors share the market. It's a takeover, and the takeover is already complete. The only question now is how long it takes for everyone else to realize it.